G'day everyone, welcome back to my channel, and in today's video I'm going to be building a Don Fog style sword heat treating furnace. I know I haven't been uploading for about a month now, but I'm glad to be back, and glad to be bringing this project to you because it's a very simple project that can be really effective for large blades. Now this drum is a 44-gallon drum, a pretty standard layout. And the first thing we're going to do is lay out for the door. Now, according to Don's design, it is a 2-inch by 3-inch door, rectangular door, and that actually is at the top of the furnace. You'll see that at the end. Now, Don Fog is a master bladesmith, the American Bladesmith Society. He is famous for designing multiple different styles of forge and furnace. He actually designed the post box vertical forge that I quite commonly use in my videos. And what you'll see me doing here is drilling holes for the stainless 306 wire that I'm going to be using to hold the insulation in. This forge is actually a horizontal forge, so it's actually going to be used with the barrel laid down on its side. And these holes will help hold the isowool, the KILN ceramic fiber blanket insulation, to the walls when it's in that orientation so that it doesn't slump into the forge and close the cavity off. It's really important when working with isowool, KILN, or any kind of ceramic fiber blanket to wear respiratory protection, because this stuff acts much like asbestos does. It has very small microfibers that will cause your lungs to create masses, which can then lead to mesothelioma and other respiratory distress. So please be careful when using this stuff. We colloquially in the blacksmithing industry call it a cancer blanket because it is pretty much that. And so as now you can see, I'm going to use those holes to put the stainless wire. Now it's important to use stainless or at least black steel wire, and not galvanized, because obviously the galvanization, the nickel content, or zinc content I should say, is dangerous for your lungs because heavy metal poisoning is a thing. But the stainless wire is also going to live longer on the surface because it doesn't oxidize as quickly. And once we have the piece wired in place for the front door, we can then cut the door opening out. I'm not going to cut the burner hole at this stage. I'm actually going to leave that until the very end, but it's easier to just cut this out at this point and start laying in the rest. Now you'll see that there's lots of little burrs from the drilling of the wire holes, and I don't end up actually using all of the wire holes that I drilled. But the thing about the burrs, you got to be very careful. I actually ended up brushing myself on one of them and cutting my arm open quite badly. You may see little specks of blood in the future, just a warning to those people that may have an issue with it. But yeah, it's something to keep an eye on. Now, in some cases, you're not going to be able to push the wire from inside out. Sometimes you're going to have to push the wire from outside in, and that's going to leave little tag ends and stuff, but it's unavoidable. It doesn't actually make a huge difference. Now we're going to lay out the isowool to go around the rim. Obviously, the circumference of the circle is going to be pi times the diameter, or pi times radius squared. So in this case, it was, I did roughly estimate 3 times the diameter and came out with a pretty reasonable result. It's what we call blacksmith's pi, is, 3 rather than 3.14. And then boring wiring. It took me a long time to find the various openings to get the wire through, so I edited this down quite a bit. And then obviously just twisted the tie wire in place with pliers. So because the blanket wasn't quite wide enough to do the whole body, we're going to have to add a little bit extra. That's no big deal. I'm making it so that the seams line up, and the seams are actually going to be at the bottom of the forge, and that's so that I can fill them with little rag pieces of off-cut isowool so that I can block off everything. You only need 1 inch of isowool in this specific style of kiln, and the theory that I have heard is that it allows enough energy to be released through the walls of the furnace in order to maintain a really even temperature. One of the great things about this specific kiln style is that it's really cheap, and you need the size of body in order to even out the temperature from a single burner. A small body based on the same design would not work because the heat would be isolated to around where the burner is. In this case, you need that extra room, the extra volume of the furnace in order to actually get an even temperature. And you'll see how effective that is at the end. But this 1 inch layer of isowool is also really important. This is a liquid rigidizer. It's a commercial product that's sold by the same pottery company that sold me the isowool, the KILN. And basically it just gets applied. It's a 50-50 mix to water, and then it gets applied, and it cures when you do the first firing. And now, at the same height as the base of the door, I am making these loops of 316 stainless TIG rod, and this is to hold the blade, suspend the blade, in the furnace when we are heat treating. So the reason I chose 316 stainless is because I didn't have any 306 or 310 stainless that was large enough. This is 1/8 inch. And I wanted something that was going to be relatively sturdy at temperature, and I also wanted something that's going to last a while as it oxidizes, which stainless does oxidize, just not as quickly as other steels. And you can see that I've just got a ring of them there, and now we're cutting the burning hole. Now, the burner hole is a 2-inch hole. On some drums, you may find that the drum lid actually already has a 2-inch bung hole in it, in which case you don't need to do this step. And I'm drilling it off-center only because I had the tie wires in place of where I should be cutting the burner hole. But that's okay, it doesn't really make a difference. And I'm using a tungsten tart carbide toothed hole saw to cut that out, and then just using my kiridashi to cut the isowool out of the entrance. Now, the 2-inch hole is actually quite important, and I'll get to that in a minute. Originally, it wasn't for why I thought it was, but I'll explain that when we get there. And then I'm just painting the new freshly cut surface with some rigidizer as well to ensure that we don't have any of those fibers flying around when we fire it up, because again, the fibers are really bad for your lungs. And now I'm just welding the lid in place. Welding sheet metal is not my favorite thing to do, and it is a bit of a pain with an arc welder. Although I could have made it easier for myself by lying the furnace down. I don't know why I didn't. But you can see that I struggled quite a bit getting this welded. But yeah, I'm only doing a couple of tack welds around the rim to make it so that the lid doesn't pop off when we've got it up to heat, because metal likes to warp. And I'm also using a differential steel rod in order to weld the TIG rod in place to hold for the loops. I'd bent it over, but that wasn't really enough for me. I wanted to weld them in place to make sure. And I'm just going to quickly show a couple of steps that I used to build a stand for it. If you want to build your own kind of stand, you can. I went really simple. Just used some uni angle from a local scrap dealer, and some bed frame rod to make the legs. It was the jankiest stand I have ever built. I do not recommend it. And I am welding on the surface of my anvil here, but I coated the anvil in a layer of WD-40, sprayed it down quite a bit, so that it wouldn't get any spatter welding to it, and it worked just fine. Like, it didn't have any adverse effects to my anvil face. The spring is only there to hold them in place, because otherwise they'd fall off. And now you can see I'm welding those bed frame tubes on. I didn't show all of that because it was a massive pain, because those things are really thin. I could have chosen better material, but I used what I had on hand. And now we can see the furnace in its final resting place, how it's going to be oriented. Obviously heat rises, and the burner being at the bottom means that the significant amount of heat is going to be at the bottom. And we're drilling a hole for a K-type thermocouple, which is going to go to a digital thermometer, which will allow me to monitor closely. Now, this is where I made a mistake. The burner tip on this weed burner, it's a weed burner for like 30 bucks from eBay. The burner tip on this is 2 inches wide. And what I didn't know was that you need to actually have the burner smaller than the orifice, so smaller than the burner hole, 2 inches, and set back from the burner hole. And this is why. It's burning itself out. And you can see I'm playing the flame over the hole there because it was running without a flame for a couple of seconds, and I don't want to create a bomb. So I'm trying to burn off any unburned LPG in there. I actually did run this for the curing cycle with this burner on a very low setting, and I managed to get it to work, but it only got up to about 500, 600 degrees Celsius, and it left a lot of unburned LPG soaked into the isoil, which then burned for about 20 minutes after I turned the burner off. Definitely don't recommend this, and after I went back and did some research, I found the answer, which was to make myself a bracket to hold the burner back from that orifice so that it gets more oxygen, because obviously there's not a lot of oxygen intake. You can see here it is running, but it's on a very low flame, and I'm not getting enough oxygen, so I have a lot of unburned LPG in there. The other thing to be aware of when running this furnace is because it completely combusts all of the LPG involved, it does create a lot of carbon monoxide, and it's really highly recommended that you run this outdoors, or at least in a very well ventilated area. I got really lucky that I didn't give myself carbon monoxide poisoning, though it was very close the first time I ran it. Now, to make the bracket, all I did was take some 32mm pipe with some 6mm wall thickness and a piece of 6x25 or inch by quarter bar. I'm drilling a hole in the 32mm pipe and tapping it for a screw that I had lying around. And that's going to be the little clamp that holds the burner nozzle. And then I'm going to weld that ring. I'm going to cut that ring off, and I'm going to weld that to the bracket. And the bracket is going to get screwed and welded to the face of the furnace. This was the simplest answer I could come up with to holding the burner in place at a distance from the opening. And just going to drill a hole for the screw. But yeah, like I said, this is a very effective, very cheap forge. This whole build, the 44-gallon drum, isoil, rigidizer, everything, in total, came to just under $150 Australian. Which is insanely cheap. And that includes the burner and everything. And once I had it all rigidized, and once I had it all cured and had the burner set up properly, I could get it up to 820 degrees Celsius, which is around 1550 degrees Fahrenheit, within 20 minutes of first firing. So from cold, 20 minutes to get to heat, which is quite impressive. And as you can see, I'm using a much smaller burner nozzle now. I'm using I believe it's a 3/4 inch, maybe a 1 inch burner nozzle, and it's set back about 1 inch from the orifice, and you can see that the flame is now perfectly registering, and we've got that really nice even heat. And you can see we're sitting at about 810 degrees. It did climb a little bit more, but then all you have to do is adjust the amount of gas you're putting in, and you can get really tight control. I was getting within 1 degree plus and minus, and I was holding that for about 30 minutes while I put a blade in there. I decided to put a blade in. It's actually the blade of the first sword I ever forged on this channel. Some of you may recognize it. I never got around to heat treating it because I never had a heat treating furnace for it. So now that I do, and you can see as I pull this out that it's super even. Look at the evenness in that. I still get chills. But as you can see, this is going to be a miraculous piece of equipment for a sword maker's shop, and it is amazing for my work. Now, I would like to say thank you to my patrons who have been really, really supportive during my down periods recently, and they have been incredibly encouraging to get more content out there, and I've been glad to be able to share behind the scenes stuff on stuff like this build and other things that I'm doing. And if you want to become part of my Patreon family, please feel free to hit the link down in the description below or in the end tags of this video. And I appreciate every single person who comes onto my Patreon crew. With that being said, I hope you all have a fantastic week. If you have any questions, please feel free to put them in the comments. Make sure to hit that like button, and if you want to see more from me, hit that subscribe button, and hit the notification bell to be notified of when I upload new videos. And if you got this far in the video, I have one simple message. You're awesome. Have a great day.